Hey everyone, thank you for tuning into our YouTube channel. This is Puzzle Me Academy, and here we have the 5th edition task list. So this has been highly requested. Everyone has been asking us to upload the 5th edition task list since, once again, the 5th edition is what's coming up for 2022. So here you have it, the 5th edition task list for the BCBA, BCABA exam. So here we're going to go through each one of the sections in the 5th edition task list, and we're going to give you guys whatever basic study material we have so you guys can have something to listen to on your car ride home or however it is that you please to listen to your material. So I really do hope that this study material finds you well, and I hope that you find it helpful for your journey to taking the exam. So once again, so excited to have you guys joining us. The 5th edition task list, this is the first section, Foundations. A, Philosophical Underpinnings. B, Concepts and Principles. C, Measurement, Data Display, and Interpretation. And section D, finishing off with Experimental Design. Just a very quick disclaimer, just for you to know. The 5th edition and the 4th edition are there's not per se new material. There's not new science. You're not going to be learning completely new concepts. It's just reorganized in a different manner. There's a couple of things that are a little bit more detailed in, and pretty much the material remains the same. It's just a little bit more oomph and a little bit more organized, I would say. Another disclaimer too. So the 5th edition task list for the BCBA and the BCABA is slightly different, only in that for the BCABAs, there is a couple of sections that we will clarify as the video progresses that have less sections. So as we get to that, we will once again clarify that information for you guys. But just a little disclaimer. Alright, so let's jump right into it. Section A, Philosophical Underpinnings. A1, identify the goals of behavior analysis as a science. So specifically here we're talking about description, prediction, and control. So these are the 3 levels of scientific understanding. That is description being the most broad, the most basic, and the lowest level. This is where we're going to have the facts. This is where we're going to be describing what we are observing. So we're going to be encountering an objective statement. This is like the hypothesis. There's no cause, just a hypothesis. Second one is prediction. This is where we're going to make a prediction. We're going to decide what the relative probability is. There seems to be some correlation, but it doesn't mean that it causes it. So this is also another type of hypothesis for prediction. And the last one is control. This is the highest level of scientific understanding. This is when you can manipulate the variables, you can determine the causation of something. This is where we're going to be able to find a functional relation. Section A2, explain the philosophical assumptions underlying the science of behavior analysis. So for this section, we're talking about the 6 attitudes of science. That would be determinism, empiricism, experimentation, replication, parsimony, and philosophical doubt. So first, I want to talk about determinism. When you think about determinism, remember that we're talking about cause and effect, that nothing is random, that there is lawfulness, there's order. Everything has a cause and an effect. Nothing just happens out of the blue. Then we have empiricism. That's the second one. These are the facts, the data, the direct observations, what we can see, what we can directly observe. The third one is experimentation. So this is when we are able to manipulate the variables, when we are able to conduct an experiment and determine functional relations. Then we have number 4, replication. So in order to be able to believe in something, we need to see it done various times and be able to accomplish the same results over and over again. So this form of repeatability allows us to have reliability, and this is how we're able to detect human error. Following up, we have parsimony. This is the simplest theory. This is an explanation of something. An explanation of something in the simplest manner. Number 6 is philosophical doubt. And here we're just talking about healthy skepticism, which is basically when we ask questions, we want to know why. We want to always question everything. On this slide, we also have pragmatism. And pragmatism is a type of philosophical position that we take as scientists. This is the most practical approach for dealing with problems or behavior. So I don't want you guys to confuse parsimony with pragmatism. So the difference is that parsimony is explaining what we see. This is the why. The simple why they do this is because of this. When we're talking about pragmatism, we're talking about the most practical approach. Section A3, describe and explain behavior from the perspective of radical behaviorism. So before radical behaviorism came into place, there was just behaviorism, and that started with Watson. This was like the typical antecedent behavior concept that we know of. Shortly after came in Skinner, and this is when he invented the idea of radical behaviorism. And this is the idea that everything is behavior, whether it is private or not. Unlike Watson, who said that behavior cannot be private events. So Skinner came along and he said that everything is behavior, regardless if it's a private event or not. And that's where the whole theory of radical behaviorism comes from. And the main idea of this is that this branch focuses on the theory and philosophy of our science and where we started. Section A4, distinguish among behaviorism, the experimental analysis of behavior, applied behavior analysis, and professional practice guided by the science of behavior analysis. So these are the 4 branches of behavior analysis. In the previous slide, we went over radical behaviorism. So this is the first branch, and it focuses on the theory and philosophy of our science and where we started. So these branches, they all go together. They are basically used interchangeably. One way or another, we're applying each one of them in our field. So just a note to self. Experimental analysis of behavior, EAB. This is something that happens mostly in labs, but it doesn't only happen in labs. It's the basic research. So the reason why it's usually referred to in a lab setting is because of that controlled setting where experiments happen. So this is one of those that involves having a controlled setting and we're manipulating around variables. But usually EAB, you think of lab. Applied behavior analysis. Basically, this is us. This is the actual technology. So our actual practice of these principles. This is when we're referring to all the socially significant changes in an individual's life. Here we're looking for functional relations. It's the applied experiment. And lastly, we have practice guided by behavior analysts. This is when others in other fields use behavior change tactics. So like OBM, everyone is using it, just different names for it. So this is referring to parents, teachers, sports, sales, all the other different kinds of fields. RBTs, you can use it for anything. So basically implementing behavior analysis in other areas. Section A5, describe and define the dimensions of applied behavior analysis. So Bayer, Wolf, and Risley, 1968. So this section is the 7 dimensions of ABA. Number 1, generality. Whenever you think about generality, you want to think about generalization, something that's lasting and spreading. we want to be able to generalize across behaviors, settings, and subjects. Number 2, effective data. So when we're talking about effective, we're talking about data that shows that change happened because of this. So that the behavior changed because of what we're implementing and that the data shows it. So clinically significant, and we're trying to figure out, does it work? That would be effective. Next we have technological. Technological is the procedures, the details, precise, exact. We're talking about everything being described, very detailed, so then the next person can come in and be able to replicate it. We want others to be able to repeat this. The fourth one is applied. Applied would be socially significant, something that creates a meaningful outcome. That would be applied. Conceptually systematic. This is basic principles of ABA, punishment, reinforcement, extinction. Basically, think about using the ABA words when you're talking about conceptually systematic. The sixth one is analytic. When we are searching for a functional relation, what is controlling what here? Having control over the situation. So if you are reading something and it's talking about a functional relation and something controlling something, we're talking about analytic functional relation. And the last one, number 7, is behavioral. We want the description of what the behavior is to be clear, concise, complete, objective, and operational. You are defining it so clearly that you are saying what is considered the behavior and what is not considered the behavior. Section B, concepts and principles. So this is the beginning of section B, and let's get to it. Section B1, define and provide examples of behavior, response, and response class. So response is one instance of behavior. A behavior is the activity of a living organism, the interaction with the environment. It would have to be more than one instance, multiple instances of a response. So one instance of the behavior is a response, and more than one, so multiple instances, would be a behavior. Always consider the dead man test. If a dead man can do it, it is not behavior. And a response class is a group of behaviors that all have the function but may have different topographies. So they all have the same function but may have different topographies. Section B2, define and provide examples of stimulus and stimulus class. So a stimulus is something that makes up the environment, something that you can sense with any of your 5 senses. It's an energy change that affects an organism through its receptor cells. So there's a formal, temporal, and a functional stimulus class. So when we're talking about a formal stimulus, we're talking about their physical features, the shape, the size, the color. That would be formal stimulus class. When we're talking about temporal, we're talking about when they occur, the time, such as antecedent. So when the stimulus is happening. And then there is a functional stimulus class, and this is the function of the behavior. So for example, when you're given a walk sign that initiates you, signs you to walk, you walk because of the function of the sign. So function of the behavior for functional stimulus class. Stimulus, 5 senses. Section B3, define and provide examples of respondent and operant conditioning. Respondent conditioning is also known as classical conditioning, Pavlovian, higher order conditioning, stimulus-stimulus pairing. Just keep those other names in mind. So before conditioning, you would have an unconditioned stimulus, such as food, as your antecedent, and then the behavior would be an unconditioned response, such as salivate. You would present a neutral stimulus. In this example, we're going to say a bell, and there would be no response. So these are the things that happen before conditioning. Neutral stimulus will present with no response. During conditioning, we would pair the neutral stimulus, the bell, with the unconditioned stimulus various times, and this will result in an unconditioned response, such as salivate. So bell paired with food will result in salivation. After conditioning, we will have a conditioned stimulus, which would now be the bell, which used to be a neutral stimulus. But after pairing, we have a conditioned stimulus. So the bell is now a conditioned stimulus after conditioning, and this results in a conditioned response, salivating. And that is more or less how conditioning works. So operant conditioning. So first we're going to talk about selectionism. This is selection by consequences. It is a scientific belief that anything that evolves does so due to the consequences of the behavior, meaning that behavior that results in positive results will survive and stay. So selectionism. Now we have phylogenetic selectionism. This is selection that occurs in the evolutionary history of a species. So this is when we're referring to Darwin, survival of the fittest. It's a variation of physical features, so evolution. And then we have ontogenic selectionism, selection by consequences that occur over one's lifetime. Section B4. Define and provide examples of positive and negative reinforcement contingencies. So here I have a little table that breaks it all down, where we have positive reinforcement referring to the future frequency of behavior increases, and positive is when something is added. So specifically for positive reinforcement, we're referring to something is added to increase the future frequency of behavior, such as praise, candy, a high five, or a laugh. Then we have negative reinforcement. So negative being something is removed, and reinforcement being that in the future, the frequency of the behavior increases. So negative reinforcement is something is removed to increase future frequency of behavior. This is usually when you're introduced to some type of aversive situation and you want to remove it. So you're escaping, you're avoiding, you're sensing some type of relief when you're engaging in negative reinforcement. Then there is positive punishment. So something aversive is added to decrease the future frequency of behavior. This could be something like spanking, reprimand, such as saying no. And last, we have negative punishment. This is when something is removed to decrease the future frequency of behavior. So something you like is presented and then it is removed, such as response cost, timeout, or receiving a speeding ticket. These are all types of negative punishment. Section B4, define and provide examples of positive and negative reinforcement contingencies. So here we have some information on the different types of reinforcements, but we're going to go into more detail on the unwanted effects and escape and avoidance in another section. So here we're just going to briefly talk about the types. So there's 5 types of positive reinforcers: is edible, activity, tangible, social, and sensory. And there's 2 types of negative reinforcement: escape and avoidance. There's also the unwanted effects of reinforcement. So just gonna briefly cover these here in this slide as well, but we're gonna go into more detail on the unwanted effects of reinforcement in another section. So there's behavioral contrast, there's relying on contrived reinforcers, effects of reinforcement can be temporary, there's an ethical concern, society thinks it's bribery, and it can be potentially harmful. Section B5. Define and provide examples of schedules of reinforcement. So there's continuous schedules of reinforcement. This is when you are giving reinforcement for every single instance of the behavior. This is also known as a fixed ratio 1 or FR1 schedule. And you want to use a continuous schedule of reinforcement when you are initiating or encouraging a behavior. You want to start with this kind of continuous schedule. This is going to show the individual that they're going to come into contact with reinforcement if they do whatever it is that they're supposed to be doing. Ratio is another word for a response, so just keep that in mind. Then there's the intermittent schedule of reinforcement, and this is when some but not all instances of behavior are reinforced. This is great for maintenance. So after you have already initiated and encouraged the behavior, you want to switch to an intermittent schedule in order to maintain the behavior. You don't want them to get bored. You want them to continue to be able to do this behavior later on. So there's also extinction. This is when we withhold all reinforcement of previously reinforced behavior. So then down here we have a key, and it breaks down fixed, variable, ratio, and interval. So just keep in mind that fixed is a set amount. Variable is an average, referred to as like about. Ratio is responses, and interval is time. So usually you'll see fixed ratio or fixed interval. So set amount of responses or set amount of time. Or you'll see variable ratio, which is an average or about number of responses, and variable interval, an average or an about of time. The variable schedules are schedules that are steady, and the fixed schedules are the ones that have a post-reinforcement pause. How you would usually implement these type of schedules is starting with an FR1 in order to initiate and encourage them, specifically because continuous schedules of reinforcement are easily extinguished compared to intermittent schedules of reinforcement, which are not as easily to be extinguished. So you start with an FR1, which is a dense schedule, and you thin out. Just an example here, we have VR2, so variable ratio to variable ratio 5. That will be thinning the schedule. Another term that goes under this section is interval schedule with limited hold, so usually abbreviated LH. This is when a limited hold is added to an interval schedule, then reinforcement remains available for a finite time following the elapse of the fixed interval or variable interval. Then there's lag schedule of reinforcement, which is variability. It's teaching something new, and this is something that allows us not only to influence rates of responding by schedules of reinforcement, but we can also increase variability of responding when we use a lag schedule of reinforcement. This is when a response is reinforced only if it differs from a specified number of responses. Something else that's also here in this slide is fixed time and variable time. This has to do with no correct response is required for reinforcement to occur. It does not equal the same thing as interval. Non-contingent reinforcement is delivered on time. This is one of those procedures, non-contingent reinforcement, NCR, that is delivered based on time, not whether the individual engaged in a correct response or not. And then, how I was saying earlier, schedule thinning is when you have an existing schedule of reinforcement where it is thinned gradually by increasing the response ratio or the time of the interval. You want to do this systematically and slowly, because if not, you will have ratio strain. And a ratio strain occurs when a schedule of reinforcement has been thinned too quickly, and the result of this is usually aggression, avoidance, a pause in responding. Progressive schedules of reinforcement result in ratio strain. Section B5 continued. So here we have the differential reinforcement, specifically DRH. So DRH is differential reinforcement of high rates of behavior. So this is behavior that isn't happening a lot and reinforcement is given at high rates. So this is used to increase behavior. Then there is DRL. This is differential reinforcement of lower rates of behavior. This is to decrease but not eliminate a behavior. This increases IRT and decreases behavior. There's DRD. Differential reinforcement of diminishing rates of behavior. This is used to decrease behavior, not diminish it. So you provide reinforcement at the end of the predetermined interval when the number of responses is less than a criterion that is gradually decreased across time intervals. So DRD has to have a DRL. DRL and DRD are the same. The difference is that DRL is implemented first, and as you continue the schedule, it is considered a DRD. Your very first DRD is your DRL. So make that association that they go one with another. Your very first DRD is your DRL. Also, whenever you want to see the biggest difference, is that DRL has to do with IRT. They do both decrease behavior, but DRL increases IRT. Then there's DRO, differential reinforcement of other behavior. This is when you give reinforcement for the absence of a behavior, of the maladaptive behavior. So you want to eliminate this behavior. DRO is used to eliminate a behavior. You aren't providing them with an appropriate alternative. You're just giving them reinforcement when the other behavior is not there. So for any other behavior, they'll receive reinforcement. DRA is differential reinforcement of an alternative behavior. You can use functional communication training is a type of DRA, and you reinforce appropriate alternative replacement behavior. So this is when you're going to implement an appropriate alternative replacement behavior. And lastly, we have DRI. This is differential reinforcement of incompatible behavior. This is when you can't do this and that at the same time. You can't stand up and sit down. You can't walk and run at the same time. This is what DRI is. You give reinforcement for a behavior that is not compatible with the other. So you can't yell and talk softly at the same time. And again, here we are with section B5 continued. Schedules of reinforcement is a really big and detailed section, so it's a lot of material. So section B5, this one in particular, refers to the compound schedules of reinforcement. Generally, the compound schedules of reinforcement is when we have two or more schedules of reinforcement in place. That's the general idea of it. So these are like the more complex schedules. This is when we start to combine the fixed interval and the fixed variable, all of these things together. So there is 7 types of compound schedules of reinforcement. First, let's talk about concurrent. Concurrent is independent, it's simultaneous, when there's two or more behaviors. But the main idea really that's going to differentiate the concurrent compound schedules from all the other ones is that it's when you're giving them a choice. They have a choice, which is where the matching law comes in. So they have a choice between two different schedules and they get to choose. And they're usually going to go with the one that provides them the most reinforcement. This one has an SD that's present, and it's used during reinforcer assessments. So now over here we have multiple and mixed. Multiple and mixed are exactly the same schedule. The only difference is that multiple schedule, compound schedule, is going to have an SD present and mixed has no SD present. So there's alternating. The schedules are random. They happen successively. And it's under one response class. So they're random. There's no order. Then there's chain and tandem compound schedules. Chain and tandem are also one of those schedules that are exactly the same. The only difference is that chain has an SD present and tandem does not have an SD present. They happen successively. Order does matter, and there's one or more response classes. So difference between chain and tandem is that between chained and tandem and multiple and mixed is that chained and tandem order does matter. Multiple and mixed, it's random. Then there's alternative, which is the first schedule is completed. Whichever one is the first one that is completed is the one that receives reinforcement. So this is when we're referring to either or. So there will be two schedules presented, and whichever one is completed first will be the one that receives reinforcement. Then there's conjunctive. This is when both schedules must be completed to produce reinforcement. So both of them, ratio and interval, have to be met in order for the individual to come into contact with reinforcement. This also simultaneously, it involves ratio and interval schedules. There's one response class and an SD is possible. So those are the compound schedules of reinforcement. Section B6, define and provide examples of positive and negative punishment contingencies. So these are the types of positive punishment. So I know on the slide it says shock, but don't worry about shock. It's not part of the 5th edition task list details. So just ignore that. It's not part of it. We don't do that. There's overcorrection, and there's two types of overcorrection. Restitutional, which is when you restore the environment to better than before. So you clean the mess and the whole house. And there is positive practice for overcorrection. Positive practice would be when you engage in positive or correct behavior over and over again. Another type of positive punishment is reprimand, such as no. It's like when you say no. And then there is exercise, contingent exercise. So this is kind of like when we're thinking about the military, drop and give me 20. You're making them do some type of exercise as a form of decreasing the future probability of the behavior. And the last one is response blocking. So this is different from extinction because in extinction, they engage in the entire behavior. In this, you block the whole behavior from occurring. So when we're talking about extinction, they have to engage in the entire behavior. But when we're talking about response blocking, you literally block the whole behavior from occurring. And that is what response blocking is. You block the behavior from occurring. And in order to effectively use punishment, punishment must be used every time behavior occurs. Section B6, define and provide examples of positive and negative punishment contingencies. So negative punishment is something you like is taken away. Just Remember that? We talked about that earlier. And there is various types. So there is response cost, which is loss of a specific reinforcer. It could be bonus or direct fine. These are the two types of response cost. And then there is timeout. And timeout is non-exclusionary or exclusionary. So the non-exclusionary would be planned ignoring, contingent observation, timeout ribbon, or taking away items. Exclusionary timeout would be room, hallway, or partition timeout. Here on this slide, we also have the unwanted effects of punishment. I'm just going to briefly name them, but we will go into more detail about the unwanted effects in a different section. So this type of procedure, which is punishment, some of the unwanted effects that you can come into contact with are that if you are the one that's providing punishment, it may negatively reinforce the individual's behavior that's giving the punishment, because they will decrease the behavior quickly and you're going to want to proceed to doing more punishment procedures. There's also behavioral contrast. The effects may be temporary. You have to model the punishment behavior. You can become a punishing agent, so become aversive. It requires a lot of supervision, and you have to prepare for emotional outburst. And always keep in mind that a high magnitude, so a high amount, and the least intensity is necessary to be effective. Section B7, define and provide examples of automatic and socially mediated contingency. So there is positive reinforcement and negative reinforcement, but there's also automatic or socially mediated. Here we have it broken down into each one, specifically positive reinforcement, automatic, and positive reinforcement with socially mediated. But I just want you to get the gist that automatic means that it's auto, to yourself. You are giving reinforcement to yourself and no one is delivering it to you. So you don't need anyone to give you this type of reinforcement. You give it to yourself. Socially mediated means that someone gives you the reinforcement. And the same thing goes with negative reinforcement as well. That if it's automatic negative reinforcement, you are removing something aversive from yourself. And if it's socially mediated negative reinforcement, someone else is removing the aversive thing. So socially is that someone else is involved. Automatic is that you are alone. Section B8, define and provide examples of unconditioned, conditioned, and generalized reinforcers and punishers. So unconditioned, conditioned reinforcers / punishers. Specifically, let's start with unconditioned reinforcers. These are unlearned reinforcers. No one has to teach you. So unconditioned is unlearned. It's not something that someone has to teach you. You're usually born with this. It's things that we need. They are primary reinforcers, such as sex, food, water, oxygen, shelter, activity, sleep, warmth, decrease in pain. These are unconditioned reinforcers. No one has to teach us to know that we need these things. We are just born with this. Conditioned reinforcers are learned reinforcers. This is something that you learned as you progressed in life. So this is not something that you're born with. This is something that after various pairings or some type of event, you learn that you can come into contact with this reinforcer. These are also known as secondary reinforcers. So somehow you've learned them, somehow with them being paired with something else. Section B8, define and provide examples of unconditioned, conditioned, and generalized reinforcers and punishers continued. So there's two types of punishment and unwanted effects of punishment. Unconditioned punishment would be unconditioned punishers. Once again, unconditioned means unlearned. Nobody has to teach you. So unconditioned punishers could be like pain, anything that makes you say ouch, something not pleasant. Nobody has to teach you to have this reflex against things that make you feel uncomfortable or that make you feel pain. Then there's conditioned punishment, which is conditioned punishers. So this is learned punishers. You had to learn it somehow. It must be paired and paired and paired again. So some type of punishment that you learned. So the typical example of the stove and placing your hand on the hot stove after that happened to you one time. The first time it happened to you would be an unconditioned punishment. And next time, whenever you're around the hot stove, you're already conditioned from when it happened to you the first time as a reflex. Now you know not to put your hand on a hot stove would be the conditioned punishment. Section B9, define and provide examples of operant extinction. So extinction is a previously reinforced behavior that is no longer being reinforced. So extinction is used to decrease or eliminate the target behavior. For extinction to be considered extinction, you have to be able to let the full behavior happen. Some things that come along with extinction are extinction burst, spontaneous recovery, and reassurance. Section B10, define and provide examples of stimulus control. So stimulus control is that we want a specific stimuli to evoke a response. So there's an SD, which is a discriminative stimulus, and this signals that reinforcement is available. Part of establishing stimulus control, we also have the S delta, which is the S with the little triangle. This signals that no reinforcement is available. Behavior occurs more often in the presence of an SD than in the absence of an SD. And this allows you to discriminate between different stimuli to control your response. Being able to do this leads to stimulus discrimination. So basically, all of this that I just said is how we're able to obtain stimulus control and why it's necessary. Now, what happens when we have faulty stimulus control is when some behavior comes under the control of irrelevant antecedent stimuli. So teaching multiple examples is important because if not, people generalize based on faulty stimulus. So the things that hinder development of stimulus control are masking and or overshadowing. Masking is a secondary or a competing stimulus that locks the evocative effect of the original stimulus, and overshadowing is the presence of one stimulus condition that interferes with the accusation of a stimulus control by another stimulus preventing learning. Section B11, define and provide examples of discrimination, generalization, and maintenance. Stimulus generalization is when an antecedent stimulus has a history of evoking a response that have been reinforced in its presence, and there is a general tendency for similar stimuli to also evoke a response. This is loose stimulus control, and it's referring to within. Then there is response generalization, also known as response induction. And this is the extent to which a learner emits untrained responses that are functionally equivalent to trained target behavior. All responses are functionally equivalent. So in smaller words, stimulus generalization is when you are able to be in different conditions, different environments, different stimuluses around you, and you're still producing the same behavior. So the same behavior is being produced in all these different conditions or environments. And response generalization is when you're able to produce a similar but not exactly the same response in different environments or conditions. So then right here in the section that says generalization and discrimination is how we're able to build concept formation. And this is by using stimulus control that requires stimulus generalization within a class of stimuli and to discriminate between stimuli. So some of the negative outcomes of generalization is when there is overgeneralization. This is something that you need to watch out for. This is the outcome in which the behavior has come under the control of a stimulus class that is too broad. Section B12. Define and provide examples of motivating operations. So first and foremost, unconditioned motivating operations are those motivating operations that are unlearned. Things that we have a deprivation of or satiation of. Deprivation of such as food, water, oxygen, activity, sleep, sex, and satiation of such as too hot, too cold, too much pain. MOs are what you care about in the moment. So right now, what matters right now, what's happening right now. Your state of value right now. So then there's value altering effect, which is the value of consequence. So something about the consequence being offered, do you care about it right now? Yes or no? So if you answer yes, you're talking about an establishing operation. If the consequence being offered is something that you do not care about right now, and your answer is no, we're talking about an abolishing operation. So those would be for value altering effects. Then we have behavior altering effects. So this is the effect that it has on the actual behavior. So are you going to do something to get whatever it is that's being offered? If the answer is yes, we're talking about an evocative effect. And if the answer is no, we're talking about an abative effect. So now we have conditioned motivating operations, CMOS. CMOS standing for surrogate. So this is something that's paired. The stimulus has been paired with an unconditioned motivating operation, which evokes the same response. So something is paired with an unconditioned motivating operation, which evokes the same response. Then there is CMOR, reflexive. This is when you're getting a signal that something is either worsening, it could be improving as well, but usually they refer to something that's worsening. It's like a warning sign. And this is something that's going to increase the value of escape and avoidance. And the last condition motivating operation is CMOT, transitive. This is like a transfer, a tool. And this is something that you could think of as like a problem solver. So something that previously had no value to you, but now it has gained value. Section B13. Define and provide examples of rule-governed and contingency-shaped behavior. So first and foremost, contingency-shaped behavior is that you are engaging in this behavior because you encountered this contingency. So usually it's from experience. There's an ABC situation going on here. So where you've encountered it in the past and then you've learned over time. So you learn from doing. The consequence is immediate. Versus rule-governed behavior, which is something that you heard. It's a rule, it's a law, and the consequence is delayed, or you may never come into contact with the consequence. And it's usually described as a verbal description of a behavioral contingency. So in order for something to be a real rule-governed behavior, it's something that doesn't have to come into contact with a consequence. Or it may be delayed. Something you heard. It's a rule, a law. Section B14. Define and provide examples of the verbal operands. So first, let's talk about verbal behavior. When we're talking about verbal, we're talking about communicating by using words, signing, pointing, anything that's listener-speaker behavior. Verbal behavior involves a speaker and a listener. You need both for it to be verbal behavior. Both have to be involved, a speaker and a listener. There's controlling relations / variables, and this also relates to the antecedent, which is multiple things that can evoke a response. There is point-to-point correspondence, and there is formal similarity. So when we're talking about point-to-point correspondence, we're talking about all the parts of the word / phrase match, the beginning, the middle, and the end. So an example of this would be when you say hello, you would say hello back, not hi. And then there's formal similarity. So talking about the same form, both are vocal or both are written. So an example of this would be vocal hey to vocal hello, not vocal hey to written hello. So both of them would have to be done the same way, either vocally, both, whatever it is that you're saying, doesn't matter, just as long as you're saying it, not saying it and then writing it. So continuing on with the verbal operands on section B14, we have a table here that shows the antecedent, the verbal behavior, and the consequence. So for all of the verbal operands, the consequence is usually a generalized condition reinforcer, except for specifically mand, which is the one that we're going to start with. So mand's antecedent is the only one that has a motivating operation as an antecedent. Mand is the most important verbal operant. It's usually the one that we teach first, or that individuals tend to learn first. It's making a request, something that they want, making a demand. And then the consequence for demand would be a specific reinforcer. So whatever it is that they're demanding, that they're requesting, is what they're going to receive as a consequence. Next we have tact. Tact's antecedent would be a nonverbal stimulus. A tact is when we're referring to something that we're labeling, something in their environment, using your 5 sentences, something that you can see, touch, taste, something that they're labeling. So if ever you come into contact with the word tact, think about something that's being labeled. And the consequence for this is a GCR, generalized condition reinforcer. Next we have echoic. Echoic's antecedent would be a verbal stimulus. And this is when we're repeating, basically. We're doing an echo. It has point-to-point correspondence, and it also has formal similarity. And the consequence for this is also a GCR. Then we have interverbal. The antecedent for interverbal would be a verbal stimulus, such as a song. Especially when you're teaching interverbal in the beginning, you would usually use songs, such as Mary had a little, and then you would let them finish. So interverbal is something that has to do with having a conversation. It does not have point-to-point correspondence or formal similarity. And the consequence for interverbal is a generalized condition reinforcer. Next, we have textual, the antecedent being a verbal stimulus, something written, and it's something that has to do with reading with point-to-point. It has point-to-point correspondence, but no formal similarity. So whenever you think about textual, think about reading. And the consequence is a generalized condition reinforcer. And the last one is transcription. So also has an antecedent of a verbal stimulus, something vocal, and it's when you're transcribing. So basically writing. Someone is speaking and you're writing. It has point-to-point correspondence, but it does not have formal similarity. And the consequence is a generalized condition reinforcer. Over here on the side, we also have codic and duplic. Codic is usually referred to as like what you would see with textual. It's like decoding. It's a transcription as well. And it just means that there's point-to-point correspondence, but no formal similarity. That's what codic is. So if you ever want to think about codic, think about textual and transcription. And then there's duplic. Just think about echoic. If it has to do with echoic, we're talking about duplic. These are just other words for describing the same thing, is how I see it. So duplic mimic, echoic. It has point-to-point correspondence and formal similarity, such as copying a text as well. Last thing we have here is the pure verbal operant. So when a man is pure, it is a man without a verbal SD. What do you want? A pure MO, not multiply controlled. An impure man would be something that's not pure and maybe has multiple controls. Then there's tact. There's a pure tact. A pure tact would be that it occurs under the control of a non-verbal stimulus and it occurs without saying, what is it? It's not multiply controlled. And impure obviously means not pure. So there's also such thing as an impure tact, and that's when you have to say something such as, what is it? Instead of them just labeling something in their environment. And here we continue on with the verbal operants. Specifically, now we're going to talk about tact extensions, mand extensions, and autoclitic. So tact extensions are generic extensions, which are the basic ones, stimulus generalization, such as you teach dog for Frenchie, and then the individual is able to tact dog for Doberman as well. Then there's metaphorical extension, which is when you're using metaphor to describe something. Then there's metonymical extension, which is like a note. There's no same feature. It's like when you see a cup and you say water instead of cup, you say water. And the last extension is syllistic extension, which is kind of like slang. Next, we have the mand extensions. The mand extensions are superstitious mands, such as reinforcement is sometimes occurring incidentally. So this specifies the behavior of an inanimate object. So it's like when you're saying, I really hope my car turns on, I really hope my car turns on, and then it happens to turn on. This would be an example of a superstitious man. And another extension of a mand is a magical mand. This is when reinforcement has never occurred in the past. So this is kind of like when you tell somebody happy birthday, but that does not affect whether they have a happy birthday or not. And the last term we have on this slide is autoclitic, which is that as a speaker, you are functioning as your own listener. This is verbal behavior about your own verbal behavior. Now we're moving on to section B15, define and provide examples of derived stimulus relations. So this is when we're talking about stimulus equivalence, which is an emergence of untrained derived relations. There's some prerequisites to stimulus equivalence, and that would be identical, such as match to sample, which is like apples to apples. That would be what identical is. You have to match apples to apples. And there's symbolic/arbitrary, which is something about them evokes some response. And then there's 3 parts of stimulus equivalence: reflexivity, symmetry, and transitivity. Reflexivity, think about it as a reflection. It has to be A equals A. So if you say apple, they have to say apple. Symmetry would be A equals B and B equals A. So whatever you teach first, they have to be able to do it in reverse. And transitivity would be like transfer. So if you teach A equals B and B equals C, they have to be able to derive A equals C without further teaching. An untrained behavior. Okay guys, we finally finished with section B, and now we're entering section C, measurement, data display, and interpretation. Section C1, establish operational definitions of behavior. I hope you guys are not falling asleep on me, so wake up. So this section is when we're talking about function-based definitions, which is when we're going to identify responses as members of the targeted response class solely by their common effect on the environment. Then there is topography-based definitions, which is when we're going to identify responses by the shape or form of the behavior. And this other last bulletin here talks about non-examples and examples and data collection guidelines, such as the onset and offset of the behavior. that will strengthen a behavioral definition. These are all things that you have to keep in mind when you're establishing an operational definition of behavior. Section C2, distinguish among direct, indirect, and product measures of behavior. So first and foremost, let's keep in mind that there's 3 procedures for measuring behavior. There is event recording, timing, and time sampling procedures. So the event recording and the timing procedures are the direct, continuous measures of behavior. Just keep that in mind. And the time sampling would be those that are discontinuous measurements. So event recording refers to using it with repeatability, so things that are repeating. Then there's timing. This is used to measure duration, IRT, latency, and you use a stopwatch or a timer. Then there's time sampling procedures. This gives you an approximation. So you divide an observation period into equal intervals. There's 3 types of time sampling procedures. They are whole interval recording, partial interval recording, and momentary time sampling. These are good to use when you're collecting data for high rate behaviors, but not useful for important/severe infrequent behaviors. Another type of data collecting method is percentage. So this is like when you have a client that got 4 out of 5 problems correct. We use percentage when we want to look at all the opportunities. There should be at least 30 opportunities. Another type of measurement for behavior is trials to criterion. This is the amount of opportunities needed to meet criteria. Criteria is a set from the beginning. Criteria is set from the beginning. So whatever it is that the criteria is that they have to meet, it's always set from the beginning. And the last measurement form of behavior that we have here is permanent product. And this is a change to the environment produced by a behavior. This measures parts of behavior such as topography and magnitude. So here we have section C3, measure occurrence. So here we're talking about count, frequency, rate, and percentage. So we're going to go into a little bit more detail on the repeatability part. So here we're talking about when behavior can be counted. So countability. There's 3 types of repeatability measures. They're rate, frequency, and acceleration. Rate is the frequency over time. Free operand. Frequency is count or tally. So we're talking about something that we can count exactly how many times. He clapped 3 times. Count. You're using tallies to determine the frequency. How many times is something happening? And the last one is acceleration. So this is rate over time. Acceleration/deceleration. How much you are responding over a time period, over an overall time period. And once again, we have percentage here. We already talked about it in the previous slide, but it's when you want to look at all the opportunities, and there should be at least 30. Section C4, measure temporal dimensions of behavior, duration, latency, and inter-response time. So we're talking about temporal extent is specifically referring to duration. To what extent? How long over time does behavior extend? How long does behavior occur for? Used for high rate behaviors. So examples of this could be like stimming and tantruming. There's also other different types of ways to collect duration, and there's total duration per occurrence or total duration per session. You can use these kind of measurement procedures when you're collecting IOA. And these are for continuous behaviors. Then there's also temporal locus. So this is referring to a point in time. And there's 2 types, IRT or latency. Temporal locus refers to that everything happens at some point in time. IRT is the time between responses, and latency is the time between delivery of the SD, so when you're given a cue, until the behavior actually starts. Section C5. Measure form and strength of behavior. This is reference to topography and magnitude. Magnitude specifically refers to as the force or intensity with which a response is emitted. And topography is the physical shape or form of a behavior. Section C6. Measure trials to criterion. So we briefly talked about trials to criterion, but this is in more detail. Just it all by itself. Trials to a criterion is the amount of opportunities needed to meet a criteria. So the criteria is set from the beginning. You're given trials, a number of amount of opportunities that you need to do something, and we're going to see how many times it takes you to be able to complete and to meet whatever that goal is. Section C7, design and implement sampling procedures, interval recording, time sampling. So here we're going into more detail with the momentary and the partial interval recordings. So remember, these are discontinuous measurements. Things that happen with discontinuous measurements is measurement artifact. Measurement artifacts are something that mean that the data is not clear. There's not a clear description of data. Why? Because we're not collecting data continuously. So this is just like a assumption, an interpretation of what the actual result is, because we're taking a sample of what behavior is happening and we're determining that to be the overall behavior. So the time sampling, specifically, we're going to talk about partial interval recording first. Things that you need to know about these is that partial interval recording overestimates behavior. It's usually used to decrease behavior. It overestimates duration, and it underestimates frequency. Behavior can occur at any time in the interval. So if we're talking about a 1 minute interval, it can occur in any time within that 1 minute. Then we have whole interval recording. This is something that underestimates behavior. It's used to increase a behavior, and behavior has to occur for the entire interval. So once again, if we're recording behavior for a minute, an interval that's 1 minute, the behavior has to be occurring for the whole entire minute for it to be considered an occurrence. The last one we have is momentary time sampling. This is something that either over or underestimates behavior, or neither. This is about the behavior happening in that moment. All we care about is once we go to check in on the behavior that it's happening at the end of the interval. So if we're talking about the 1 minute interval, you wait right up to the end of the 1 minute interval, you check in. If they're doing what they're supposed to be doing, it counts as an occurrence. And play check is a variation of momentary time sampling. So it's the same exact thing. It's just when we're referring to a group of students, for example. So you check in, but on a group. Are they doing what they're supposed to be doing? Section C8. Evaluate the validity and reliability of measurement procedures. So there's indicators of trustworthy measurement, and these are validity, accuracy, and reliability. Validity, you want to focus on the relevant dimension. Does the method of measurement you are using measures what you intended to measure? So if you're talking about measuring weight, we're not going to measure how much time you're spending at the gym. We want to measure your actual weight on a scale. That would be relevant dimension. Then there's accuracy, the extent to which the observed value matches the true value. And then we have reliability. So reliability, think repeatability, repeated. This is when we have repeated contact of the same results repeatedly, the same results over and over. When we have repeatability, we have believability. So this is a very important section, C9, select a measurement system to obtain representative data given the dimensions of behavior and the logistics of observing and recording. Wow, what a mouthful. So these are the threats to trustworthy measurements. We just went over the validity, reliability, and accuracy, but these are the threats to them. So threats to measurement validity is indirect measurement. Direct is obviously better. Measuring the wrong dimension, and measurement artifacts, which comes from collecting discontinuous data. This is what appears to exist when we have threats to measurement validity. Then there's threats to accuracy and reliability. They go together, they have the same threats. It's measurement systems. If they're too complex, nobody's going to be able to replicate them. Then there's observer training. If the training isn't done properly, we're going to have our supervisees going through observer drift, or supervision isn't good, so they're not going to be able to determine the operational definition correctly or to apply the behavior treatments how they're supposed to be applied. And then the last one is unintended influences on observers. So this is reactivity. That's why we have naive observers or measurement bias. These are all the things that are threats to accuracy and reliability. So we already went over measurement artifacts. It has to do with collecting discontinuous measurements. And it appears to exist because of how it is measured poorly. When we have scheduled measurement periods that are not appropriate for the specific behavior that we're recording data for. There's measurement bias. This is that when we have our observers lean onto one direction, so our data is not accurate. It's a form of inaccurate measurement in which data over or underestimates the value of the event. And the last word we have here is observer drift. So it's when we drift from the operational definition. This is an unintended change in a way an observer uses the measurement. These are all the threats and things that we want to avoid occurring. Whoa. Section C10, graph data to communicate relevant quantitative relations. So here we're going to focus on the equal interval graphs, bar graphs, cumulative records. There's 5 types of graphs. The bar graph, the line graph, cumulative record, and scatter plot are all equal interval graphs. The only one here that's not an equal interval graph is the semi-logarithm. It's not equal intervals. It's non-equal interval graph. So first let's talk about the bar graph. It's also known as a histogram. It's used for comparison. Some pros about the bar graph is that it's great for summarizing data and it's great for comparisons. Some cons is that it does not allow for visual analysis or inspection of variability or trend. Second graph we have here is the line graph. This is the most common. This is the typical one we usually use. It has the y and x axis, how you normally see. It's also known as a frequency polygon. And it has the dots that connect. Then there's the cumulative record. This is the type of graph that you're going to see that never decreases. It never goes down. It might go flat, but it will never go down. Its data path resets to 0 when the number of responses exceeds the upper limit of the y-axis. There's also slopes. You can see a slope. So if there's a steeper slope, that means that there's a higher rate of responding. The overall response rate is the rate of response over a given time period. And then there's a local response rate, which is the average rate of response during periods smaller than overall. Then we have the semi-logarithm. So this is where the intervals are, for example, 1, 2, 4, 8, 16, 32, 64. They're not equal intervals. It's not like how the typical other ones are, like bar graphs and line graphs, that they're equal. These have unequal intervals. It's known as the multiply and divide chart. There's 4 types. There could be daily, weekly, monthly, and yearly. It's made by Lindsay. There's a standard acceleration is the other name, where you would see a semi-logarithm, standard acceleration, and it's usually used for precision teaching. It measures frequency, ratio, and it looks at the behavior change through proportional or relevant change. So the last graph we have here is a scatter plot. This is a graphic display that shows relative distribution of individual measures in a dataset with respect to the variables dissipated by the x and y axis. In other words, the scatter plot is good to use when you want to determine when the behavior most oftenly happens when we're referring to a time period or an environmental situation. So if we want to know what's the best time to collect data, we can use a scatter plot. So how it says here that ABA uses it to determine temporal distribution of the target behavior. The data points are unconnected. Section C11, interpret graph data. So here I have a little graph, very simple graph, just kind of to show you guys the idea of a graph and what it looks like. Very simple, where the y-axis is, other names for the y-axis such as vertical axis, ordinate. It's where the dv would be, which is the behavior. The dependent variable is the behavior. And then we have the abscissa. I don't know how to say that, honestly. Never know. It's the x-axis, also known as the horizontal axis, the IV, independent variable. This is usually where we have the interventions or time. So other ways to interpret graph data is through variability, trends, and level. So variability is when we're referring to low variability, high variability, no variability. So where the points are and how far they are from each other. And that will determine if there is low variability or high variability or no variability. Then there's trend. Zero trend, increasing trend. So like on this graph here, we have an increasing trend. So because the line is going up. And then there's decreasing trend. So if it was going down, we would have a decreasing trend. Zero trend would be if it was flat. And then there's level. Level could be high, moderate, or low. It's used to compare. So usually when we have a baseline and then an intervention, we would compare the lines and see if the behavior is happening at higher levels or lower levels or moderate levels to determine how much the behavior has changed. So these are the methods for interpreting data through visual inspection of graphs. And here we are with section D, experimental design. All right, so here we have section D1, distinguish between dependent and independent variables. So these are the parts of a graph. So guys, I just want you to see here that under dependent variable, we have treatment time and days, but just focus on this. The DV is the behavior. The IV would be the treatment time and days. So just focus on this as your guide for the X and Y axis. Everything else on this slide is correct. It's just the dependent variable would be behavior, and the independent variable would be treatment time and days and sessions. So we also have the origin, which would be the intersection. We would also have the condition change lines. If there's a dotted condition change line, that would be a minor change. And if there's a solid line, that would be a major change. Section D2, distinguish between internal and external validity. Internal validity would be the independent variable. It is the intervention, everything we are controlling internally in our experiment that is changing the behavior, not an extraneous or confounding variable. When we're talking about extraneous variables, we're talking about the antecedent, the setting events, the environment. When we're talking about the confounding variables, we're talking about something that we're going to find out after the fact. If you have high internal validity, you have high experimental control and functional relation. Both extraneous and confounding are variables that could affect your study and results. Then we have external validity. This refers to the external world. So after we do our experiment, will it be able to generalize in settings, behaviors, and subjects. Will whatever you are doing in your experiment generalize? And would it be able to be applied externally to the world or other studies? And the last one we have here is social validity. This is referring to the applied, what's socially significant for the individual. We can find out social validity using questionnaires. So after the study, you want to ask the parents, you want to ask the teachers, you want to ask whoever, did this make a difference on the behavior? Section D3, identify the defining features of single subject experimental designs. So this is where the individuals serve as their own controls. There's repeated measures. We're referring to prediction, verification, and replication. So first, let's look at the fundamental properties of a behavior change. We would look at level, trend, and variability. So level is the value on the vertical axis in which a series of data points are plotted. Here we're wondering if the behavior changed. That's what we can determine with the level. We would be looking along the y-axis. Then we have trend. This is the general direction in which data path takes. It can be gradual or steep. This is ascending, descending, or no trend, which would be stable. Next we have variability, the extent to which the data points move around on a graph. High degree of variability equals bad for internal validity. Low variability equals stable, which equals high fidelity. Implementing the way you design the plan to be implemented. The bigger the bounce, the higher the validity. The lower the bounce, the lower the validity. Now we have baseline logic and patterns of baseline. When we're referring to prediction, this is going to be if nothing changes, behavior level will stay the same. That's what a prediction would be. Then we have affirmation of the consequent. This would be that you would predict that behavior will change when we introduce the IV. Then there's verification, which is that you would take the independent variable away and behavior goes back to baseline like we predicted. It will verify your independent variable is responsible. And last, we have replication. Now we predict that the dependent variable will change the way it did. This allows us to have believability and repeatability. All right. Section D3 continued. Specifically, we're going to go into baseline intervention. If there's a descending baseline, if you want the behavior to decrease, you do nothing. If you want the behavior to increase, then you implement the independent variable. For ascending baseline, if you can and you need to increase the behavior, you have to wait it out. But if you want it to decrease, you get in there now. If you have a baseline that's variable, that there's no clear trend, and you can't tell if your IV is working or not because it's all over the place. So you would have to wait it out as well if you have a variable baseline. Unless you have an SIB, then you should go ahead and implement the intervention as soon as possible. And lastly, we have the stable baseline, which is the best time to introduce the independent variable. And this would be the best situation to demonstrate experimental control. Section D4, describe the advantages of single subject experimental designs compared to group designs. So for a single subject design, each individual serves as their own control. The goal for this kind of design is to demonstrate experimental control. To have a functional control, to have functional relation, we want to determine if the IV caused the change in the DV. Remember that the independent variable is intervention and the dependent variable is behavior. So the advantages of using single subject experimental designs compared to group designs is that we're getting an individualized result versus group designs that just shows you an accumulation of results. Section D5, use single subject experimental designs such as reversal, multiple baseline, multiple element, and changing criterion. So here on this slide we have reversal withdrawal. You must have at least 3 phases. So these are just some things that you guys have to keep in mind, little quick bulletins that you can jot down in your mind that are most important to know about each of the experimental designs. So continuing, it's the most powerful at demonstrating experimental control. Baseline is required. Treatment is withdrawn or reversed. Experimental control is strong with repeated replication. So the more we repeat the treatment and baseline conditions, the more experimental control we can demonstrate. Withdrawal would be removing treatment, going back to nothing. Reversal would be you are reversing to something else. There's the ABAB. There's the ABA, which would be a weaker variation. And if you just have an AB, which would be baseline treatment, that's very weak. Next, we have the disadvantages for reversal withdrawal design. It can be unethical to remove effective intervention. It can't be used with irreversible behavior. So behaviors that can't be unlearned, like riding a bike. You might have sequence effects, which means that you don't go back to baseline immediately because the effects of the intervention are still affecting the behavior. And there's carryover effects. We also have variations of reversal design, such as repeated reversal, which would be going back and forth from baseline to treatment various times, as you see here, A, B, A, B, A, B. There's BAB, which would be starting with treatment and then going into baseline and then going back to treatment. It's a 3-phase reversal. It starts in treatment. This is when you need to implement treatment ASAP, or there's treatment already in place. There's also another variation. It's called multiple treatment design. This is when you compare 2 or more interventions, and it would look like A, B, C, A, C, B. That kind of design. Then there is NCR reversal, the control procedures for positive reinforcement. The NCR is used as the control instead of a baseline. This demonstrates reinforcement must be contingent on a response to be effective. And how it would look like on a graph is that you would see baseline, then non-contingent reinforcement, and then there would be another phase change to contingent reinforcement, and then you would go back to non-contingent and then contingent. Then there's DRO, DRI, DRA reversal. In this situation, you would use a control procedure for positive reinforcement, and you would use DRO, DRI, DRA as the control instead of baseline, and this allows us to examine contingent reinforcement. Once again, it would look like baseline, then you would go to contingent reinforcement, DRO, contingent reinforcement, DRO, contingent reinforcement. Moving on, the next design we have here is the multiple baseline design. This one is the most widely used. It's highly flexible. Reversal is not required. The most commonly used out of all the variations of the multiple baseline design would be the multiple baseline across subjects. It's displayed in staggered steps. You use it when it's unethical to remove an intervention. And it is one treatment across either subjects, settings, or behaviors. Some advantages of the multiple baseline design is that the IV does not have to be removed. It evaluates generalization, and it's easy to implement. Some disadvantages is that the IV may be delayed for individuals. The functional relation is not directly shown, and there is a weak control. There are 3 variations for the multiple baseline design. There is delayed multiple baseline design, multiple probe design, and non-concurrent multiple baseline design. Delayed multiple baseline design is effective when limited resources keep from conducting a full-scale design, when a new behavior, subject, or setting becomes available, and visually the baselines won't have all started at the same time when there's shorter baselines. The multiple probe design demonstrates that data probes are taken during baseline instead of continuous measurement. The intermittent measures, also known as probe, provide the basis for determining whether behavior change has occurred prior to intervention. This is a good one for generalization and maintenance of behavior, and it's useful for teaching and shaping procedures. And the last one is non-concurrent multiple baseline design, which consists of related series of A-B sequences conducted across subjects at different points in time. Data is taken non-concurrently, which means not at the same time. This is a frequently used type of design in ABA. When concurrent measurement across subjects is not possible, would be a good time to use a non-concurrent multiple baseline design. It's weaker variation of multiple baseline, and you want to consider that taking data on multiple subjects at different points in time is useful for this type of design as well. So now we're going to talk about changing criterion design. So this can be for a behavior we want to decrease or increase. When it falls on a predetermined line, then it is demonstrating experimental control. We need baseline to be able to implement treatment because we need to know where the client is. It's only used for one behavior, so there's only one dependent variable. There is a series of treatment phases. Change will be noted to be gradual, and whatever is implemented must be in the client's repertoire. So keep in mind also that changing criterion design is not used for shaping, because shaping is used for new behaviors, novel behaviors. Changing criterion design is something that has to already be in the client's repertoire, and shaping is not something that is in the client's repertoire. It's used for new behaviors. And functional control is demonstrated when the data points fall around the set criterion. There's three things to consider when you're using changing criterion design, and that is that you have to vary the length of the phases, the magnitude of the criteria changes, and the number of criterion changes. Some advantages is that there's no reversal required, and it gradually improves a behavior. And some disadvantages is that it must be in the client's repertoire and that it's not used for shaping. And finally, the last design is alternating treatment design. It's used to graph a functional analysis. There's a couple of AKAs that you need to know for the alternating treatment design. So keep those in mind: multi-element, multiple schedules, concurrent schedules, simultaneous treatment. So this type of design is when there's two or more conditions presented in a rapid alternating succession. It demonstrates stimulus discrimination. There must be an SD used to indicate that each different condition is being implemented. Some of the pros for an alternating treatment design is that it minimizes sequence effect and carryover and irreversibility effects, which is a con for withdrawal/reversal design. It can be used with unstable data. There's no need for baseline. You do not need to withdraw treatment. There's a quick comparison of the condition of treatment to treatment, and you can quickly compare different interventions. Some cons for the alternating treatment design is that there's multiple treatment interference, which is when you have multiple treatments rapidly interfering and the treatments themselves can interfere with each other. And also, another con is that the rapid alternation is sometimes considered not natural. Section D6. Describe rationales for conducting comparative, component, and parametric analysis. So this is when we have manipulations of the independent variables. So specifically for a parametric analysis, we're talking about a dosage. So how much of the independent variable are we using? So there's going to be one independent variable in different amounts. When we're talking about non-parametric analysis, we're talking about on or off. So either we have the independent variable present or we don't. Next, we have component analysis, which is usually in a treatment package, and its components. So when we're referring to components, we're talking about an entire treatment package, and we would refer to like functional communication training, DRO, and a VR5 schedule. And what you would do in a component analysis is that you would take only one out at a time or add only one in at a time to see which component is helping. So this is when we're talking about a component of a treatment package, and we're implementing one at a time to see which one is most effective and if there's one that we can remove or replace. Okay guys, so that's the end of this video for section 1. You made it to the end of section 1. Section 2 video is also available on our channel, so go ahead and watch that one as well if you want to finish the rest of the task list. I do want to let you guys know that keep in mind that all of this presentation, along with section 2 as well, is just a brief understanding of the material. We give you guys as much material as we have possible, but it wouldn't be realistic to say that we can make a 6-hour video of all the information. So I really do hope that you guys can take this information and learn some stuff with it and use it to study. And yes, go to our channel if you're ready to watch section 2. Thank you so much for watching.